We will now look at the tables on pages 50, 51, and 52, which will be filled by using the preliminary data from pages 48 and 49.
It's what we call the straightforward and filling in blank. All we're going to do is group all the metal ions according to the reactivities. You will see on top of each table, we ask a student in the italics and the all capital letter, group your ions and then group your finished product mutually exclusive. Simply in science means if something is in one place, cannot be another place simultaneously. All right, so we're going to see how this one play out during our grouping. All right, first table on page 50, you are asked to group our ions based on the reactivity with magnesium. Well, on our page 48, there are only two criteria, all right? Two criteria. One is reactivity, no reaction. One's reaction. There are just two. Now students sometimes get paranoid. Oh, what do we do with the next two lines, next two rows? Well, we don't have them. Don't try to create them, all right? Leave those two rows blank. Leave those two blank. Now the other question, student asks, oh, can I have a reaction first and no reaction second? Yes, you are the one dealing with, you are the one process with the data, you are the one make the decision. However, in science, we always say, do it methodically, do it in a sequence. And then I see our table, no reaction first. Now what's the only reason I said our no reaction first? If you want to have a reaction first, of course. And then we have a barium ion, and the potassium ion, and the sodium ion, calcium ion, and also our strontium ion. And then reaction, well, rest of copper 2 ion, and then chromate 3, nickel 2, and then cobalt 2, and manganese 2, and our beloved iron 3, and then leave those two blank. All right, and then following one, you are asked to group all your ions based on the reactivity with ammonium sulfate. Well, simply, I had no reaction first, so I will use that. And page 49, you can see no reaction first. All right, I'm going to do no reaction first, which is copper 2, and then chromium 3, potassium, sodium, and cobalt 2, manganese 2, and iron 3. Oh, nickel 2. All right, and then reaction, barium, and strontium, and calcium. Do it for the rest of the table. And third one is reactivity with sodium carbonate. Same thing, no reaction first and reaction. Okay. All right, so now no reaction. We only have those two. And the rest of barium ion, copper 2 ion, chromium 3 ion, nickel 2 ion, cobalt 2 ion, strontium, and manganese 2 ion, calcium ion, and our beloved iron 3 ion. And then the next following one is also reactivity with our sodium hydroxide. And we have a barium ion, potassium, and the strontium, and of course we have calcium, and copper 2, chromium 3, nickel 2, cobalt 2, and manganese 2, iron 3. Now, the last one, which is on page 52. Remember our last column on your page 49. Not only we take a reaction, no reaction, now no reaction, right? We had two reaction type. In other words, this time we have three criteria. No reaction, reaction, reaction. One type of a reaction, it's a color change of the solution only. Second one, it's not only color of the solution change, also the reaction generate PPT. So we're going to do that, make our life a little more interesting or harder. And then we have last one will be the calcium ion. Okay, the reaction, first one says color change only, so we have a color change only. Second, not only color changed, but also PPT was formed. So cobalt 2, copper 2, and nickel 2, and cobalt 2, all right, in this order. And chromium 3, manganese 2, and iron 3. So the next
one. Using all of the chemical properties, we will now create one combined classifying scheme on pages 53 and 54.
Move to our final table on page 53 and page 54, all right? So what we're going to do now is by massaging all 5 reactions into each, all right, each and every final tables. Every single final table contains the reactivity with magnesium, reactivity with ammonium sulfate, reactivity with sodium carbonate, reactivity with sodium hydroxide, and reactivity with ammonia. All right, so let's see how this is going to play out. Now we massage everything all together. Same thing. When you do your final grouping, you still need to do it methodically and in sequence. Do it one by one by one by one. All right, try not to massage all 5 criteria all into one table at the same time. All right, let's see how we actually process this. Mutually exclusive, it's still in mind. All right, so we're going to name our first one. Now, can you name it A, Yes, you can. Can you name it alpha? Yes, you can. As long as you do it consistently. All right, so we're going to use just 1, 2, 3. All right. First, reactivity with the magnesium. You can see right there on our first table. It's a magnesium. But we have 2 criteria. One is no reaction. One is a reaction. Remember, we said mutually exclusive. So if you have no reaction in one place, and then the reaction cannot be in the same table. All right? So I see no reaction first. So I say, all right, no reaction. It's the reactive. What are they? Which one of our ions belong to this group? Well, barium, potassium, sodium, and strontium, and calcium. Beautiful. Remember, we haven't finished our first reactivity yet, so don't move to the next one. You go to the next table. Remember, cannot be simultaneously. So before was no reaction, so now it must be the second one, reaction. All right, what are they? They're copper 2, and chromium 3, nickel 2, cobalt 2, manganese 2, and iron 3. Now, little trick to all of you. Once when you finish one so-called preliminary table, crossed. All right? That means now it's gone. You don't go back to fool around again. Remember, all your material must be all covered. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So all right there. All right? All right there. So everything is right there. 11 of them all right there. Okay? Very good. So now we have done that. Second one, reactivity with our ammonium sulfate.
Look at your page 50 for ammonium sulfate. There is no reaction or NR listed first. So we will give that criteria to the first table on page 53. We see few of the elements do not fulfill this criteria.
So now look at your second table on our page 52. Then three of them reacted. They don't belong to this. What do? We needed to move those 3 out. Remember, we still have 2 more empty tables waiting for us. So now, can you move those 3 to our second table? No, because the reactivity with the magnesium forbid. So now we're going to move to the third table. Barium, strontium, and calcium. The reactivity with ammonium sulfate is a reaction based on that. All right? Remember, common mistake a student have their homework, midterm, and final is they leave those preliminary grouping on the original table. You can't do that. Simultaneously, no. You have to erase. All right. So now, ladies and gentlemen, your question is, oh gee, what would the reactivity with the magnesium? you have already decided before you move ions out, so you cannot change it. So must be no reaction. Once when you finish this part, now you have to go back to look for your second table and the reactivity with the ammonium sulfate. What is it? Well, right there says no reaction. All right, so you say no reaction. Once when you finish all those, you have to check. Are they all counted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, they're all counted. Once when that's done, you come back, cross it. All right, cross it. So that's how you do it. Now you move to third criteria, which is our third table on our page 51. All right. Are those no reaction? Yes, it says so. No reaction. So beautiful. No reaction. And then 1, 2, 3, 4, 5, 6 of a second table. What are they? They are all react. All right, they all have a reaction. How about those three? 1, 2, 3. Well, based on our previous work, they all have a reaction. Well, then you have to say they all have a reaction. All right, then move to your fourth one, which is our fourth table right there. Says the reactivity with the sodium hydroxide. 1, 2, no reaction. All right. And then 1, 2, 3, barium, strontium, and calcium, no reaction. Oh well, so those three, no reaction. And then how about those 6? Right there says reaction. All right, then you say reaction. Now we're going to deal with our last and criteria, which is the reactivity with ammonia. You have 1, 2, potassium and sodium, potassium and sodium, no reaction. All right. Barium, strontium, calcium, barium, strontium, calcium, no reaction. Beautiful. Now we have a reaction. In other words, all 6 ions right here in group 2 all reacted, but some of them, 1, 2, 3, had a reaction, the solution, color of the solution changed. And then the other 3 not only have a color of the solution changed, but also generated the PPT. So we're going to single those things out, all right? I see color change first. So I say, all right, reaction with a color change only. And then that will be copper 2, nickel 2, and chromium. So chromium 3 singled out, and manganese 2 single out, iron 3 single out. What do? We'll move those 3 somewhere else. Obviously, you cannot move to the table 1. You cannot move them into table 3. Table 4, it's the one you're going to move to. So we'll have a chromium 3, manganese 2, and iron 3. Ammonia, not only color change, but also PPT. What do we do? Oh, how should we fill in the blank, 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 blank? Remember what we said before. All the criteria have been decided before we move those 3 ions into another group. So you cannot change reaction. You cannot change no reaction. You cannot change reaction. You cannot change reaction. Now you finish all our 1, 2, 3, 4 on page 51. 53 and 54. All right? 1, 2, 3, 4. We have generated and answer the practical question, application question on page 55, and submit your work to your professor for your in-class credit. And good luck.